In this video, we're going to take a look at how to rationalize the denominator of a fraction. And just for all you that don't know what rationalizing means, it means to eliminate any of the radicals that are in a denominator. So when you're asked to rationalize a denominator, you must eliminate the radicals that are in the denominator. And we're going to do that by using the product rule for radicals. So, Amelia, this is for Amelia. I have marked each of the example problems with a number or numbers next to them. They refer to similar problems that are on the homework that I'm asking you to do. And there's 8 problems on the homework, so I have almost a problem for each one. All right, so we need to rationalize the denominator, and we know that when we have a square root, right here we have a radical in our denominator, we need to eliminate this radical. When we have a square root, we need groups of 2. So I only have 1 3 here, so in order to get another 3 under the radical, I need to multiply by another radical 3. But I can't just multiply the denominator by 3. I have to multiply both the numerator and denominator by 3 because that's like multiplying by the number 1. When we multiply by the number 1, it does not change the value of our fraction. If I don't multiply by the number 1, then it changes the value of my fraction and it's no longer equivalent. So I multiply by radical 3 over radical 3. And when I do that, I get radical 6 over radical 3 times 3. And this is a nice group of 2 3s, so it gets pulled out of my radical. And I have radical 6 over 3. And that's the answer to my problem. This fraction here is equivalent to what we started with. They are equal or equivalent. Okay, so my next example, now I have a fraction under a radical, so the very first thing I'm going to do is I'm going to separate the numerator and the denominator into their own radicals. When I start these problems, I typically look at my radicals, so look at your radicals and decide if you can simplify any of them. Well, I notice that 4 can be simplified because I know 4 is 2 times 2, and there's a group of 2 there, so I get 2 in the numerator and the square root of x in the denominator. So again, this is a square root. I need to have groups of 2, so I'm going to multiply it by another radical x. So I have 2 x's in my denominator. And again, I have to multiply by the number 1. So I get 2 radical x over x times x, which is a group of 2 x's. So I get an x that comes out. And my final answer is going to be 2 radical x over x. All right, for the third problem here. This one is very similar to problems number 3 and 4 on your worksheet. So again, I usually start off by simplifying, and I know that 8 can be factored into 2 times 4, and 4 is 2 times 2, and we have an x. And I know there's a group of 2 2's, so I'm going to pull out one of the 2's to get 3 over 2, and then I have a square root of 2x left, right? Because I still have my 2x under the root. So I still need groups of 2. I need another 2. I need another 2 in my radical and another x in my radical, or else this radical will not simplify. So I'm going to multiply, because we're looking for groups of 2. To get another 2 and another x, I need to multiply by the square root of 2x. So I get in my numerator 3 square root of 2x, and in my denominator, remember, I multiply what's under the same radical. I get 2 times 2 times x times x. I have a group of two 2's and a group of two x's. They come out. And my final answer is going to be 3 square root of 2x over, I have to multiply these two, 4x. Final answer. Okay, my next problem, I need to get rid of the square root of 7, and I notice both the square root of 3 and the square root of 7 are prime. I can't reduce those radicals. So I'm going to just start off by multiplying. I need another 7 under my radical to get pairs of 7, a group of two 7's. So I will multiply by the square root of 7 over the square root of 7. And when I do that, I multiply the 3 and the 7 in the numerator to get 21. And in the denominator, I get the square root of 7 times 7, which is a nice group of 2. So my 7 comes out, and I'm left with negative 2 square root of 21 over 7. And I know if I simplify 21, that breaks down into 3 times 7, and I don't have a group of 2. So that is it. Final answer for this problem. Number 6. This problem is very similar to number 6 on your worksheet. All right, so how does 25 break down? Because we should see whether we can simplify that. Well, 25 is just 5 times 5. And I want you to notice that in order for this radical to go away, I need a group of 3 5's, but I only have a group of 2 5's. So I'm going to get another 5 underneath. It has to be a cube root so that I can multiply what's underneath. Otherwise, I won't be able to multiply. So I'm going to multiply by the cube root of 5. So in the numerator, I get 4 times the cube root of 5 over, now I have 5 times 5 times 5. I have 3 5's in my denominator. So that group of 5's comes out, and I end up with 4 cube root of 5 over 5, and that is my final answer. The next problem that I'm going to do is to rationalize another cube root, and again I need groups of 3 for this to go away. But I only have 7 is prime, it does not factor any further. I only have 1 7 and I only have 1 x. So I'm going to put 2 7's and then 2 x's, and that's what I'm going to multiply by. 2 7's and 2 x's. So now in my numerator, I actually have 49 x squared, and this is a cube root again, and I forgot to write my cube roots. All right, and now in the denominator I have the cube root of 7 times 7 times 7 and x times x times x. So I have a group of 3 7's and a group of 3 x's. So both groups get to come out because they are completed. And I have 3 cube root of 49x squared all over 7x. And the last problem I'm going to do is similar to problem number 8 on your worksheet. I'm going to rationalize this. So I'm going to split the numerator and the denominator into 2. Into their separate radicals. I notice in the numerator that I can't simplify that, but in the denominator I notice that maybe I can, because 50 is 2 times 25 and 25 is 5 times 5. So I do have a group of 2 here, and I'm going to go ahead and pull that out. And I end up with 3x over 5 square root of 2. So now I need to get rid of this radical in the denominator. I have 1, 2 in the radical, so this is a square root, so I need another 2 under the radical. So when I multiply, I have square roots, so I can multiply what's underneath. 3 times 2 is 6. And then I get 5 square root of 2 times 2. And I have a group of 2 here, and I pull it out. So I get the square root of 6x over 5 times 2 is 10. And we are finished with this video. I hope those problems help you on your homework.